Click. And we're live. Today is Friday, July 30th. It is 5:01 p.m. The storms of yesterday have temporarily cleared, and we're lucky enough to be joined by Meghan Holst and Amani Webber-Schultz, shark researchers and hosts of the Sharkpedia podcast, to talk about all things shark. Meghan and Amani, thank you so much for being here today. And I'm so excited that you guys agreed to come on in lieu of fun.
Yeah, thank you so much for having us.
Hey, I just want to say it has been like 482 episodes of In Lieu of Fun, and we have not done a single shark episode. And I consider that a personal failure on my part because I love sharks and I see their menacing faces and I feel seen by them in their blank gaze, and I feel like I've let the set of the genus down by not doing earlier shows on In Lieu of Fun about sharks, and so I'm so thrilled that you guys are here.
Yeah,
we're happy to be here.
And I hope that we can change your perspective on thinking that they're menacing. That is definitely one of our goals.
Okay, I want to, let's start there because they have this, one of the things I love about them is the vacant stare as they approach you with, the sense that you are entirely expendable and they are, eating machines and you are prey, if you exist at all. And I respect that so much about them. So why am I wrong?
Yes.
Who wants to go first?
I'll go first, how about? And then Amani, please help drive the train home. So first of all, they're definitely not like fear, or they're not this monster eating machine that you might think. They're actually incredibly cautious. So if you watch them hunt, it doesn't matter if they are starving and haven't eaten in over a month. It doesn't matter if they're full and they just ate a whale earlier that day. They are going to be extremely cautious to everything that they approach because they're very, very cautious predators. And that's why oftentimes if you watch Shark Week or something, you might see them kind of come up or they might bump something first. And the other thing is that their eyesight is actually often not very good. We don't know a lot about their eyesight, but they're not using their eyesight very much when they're looking for their prey. They're using some other senses, including electrosensitivity with their ampullae of Lorenzini. That's their sixth sense. So we have sight and smell. They have all those things as well, but they have some extra senses that help them find their prey, including the ampullae that can sense the electricity pulses that happen in our muscles. So that's how they find fish and things, is by those electrical pulses in the fish. They also use their lateral line. So if you look at any fish, not just sharks, they have this line that goes down their body, and that is a line of highly specialized cells that have a hair inside. And when something goes past them, the hair moves, and they get a sense of their surroundings based on that lateral line. So that gives them kind of this like 360 vision with this lateral line of hairs that's on their skin. So they're not necessarily relying on their eyes. They probably look wide-eyed because they just don't have great vision. But they also, we are not their prey. We are not their prey at all. And that's why when you hear about incidental bites, that's just it. They're biting. They're not coming back to consume the person because we're not one of their prey items. They often will have this incidental bite and go, oh, that's not at all what I wanted. This doesn't taste good at all. And then they move on. So they're really cautious creatures. They don't want to eat us. And when they do, it's a mistake and they move on. Amani, please, what did I miss?
Oh, Amani, I think you just muted yourself quickly. It happens.
Okay, did I fix it? Okay, so I'll start out with saying in the last 3 months, I have been within a foot of probably 80 sharks, varying from under 2 feet to over 9 feet. And none of them have ever tried to bite me. None of them have ever been even interested in me. We, like Megan said, we're not a natural prey item for them. So that means that when they see us, they're not thinking, oh, I'm just going to go bite whatever the heck that is over there. I'm going to like it. We know that sharks have like favorite meals per se. Like we know that hammerheads like rays because that's a prey item that they eat a lot. When we do research, a lot of times, depending on the fish that we have as bait, we get varying types of sharks. And there's some bait that we almost never get sharks on because it's just not a prey item for them. So when we go into their home, right, they're not shark infested waters, they live there. That's like their environment.
So what I'm hearing is they're good neighbors.
They are.
Yeah, I mean, basically, like you're going into their home and they're not swimming around thinking, oh, there's an invader and I'm going to eat them now. We have to remember that like we have fingers, right? So when we're curious about things, we go touch them. Sharks don't have fingers. So a lot of times on Shark Week, like Megan said, you'll see them like almost like boop something, like hit their nose on like a camera. And sometimes that shows up as them like nibbling at something. And that can be super catastrophic for us because of how our body is and how our anatomy is. But they're not like swimming around to then come eat us. And I also will say, I mean, I think the most recent news story that came out is it's an article that says like shark attack survivor had to go to the hospital because he jumped on a 3.5 meter shark. So like we shouldn't even be using shark attack in that sentence because he provoked like, the shark. No, like he jumped on the shark. It is entirely his fault that he jumped. We would not jump on a lion. We wouldn't even jump on our own dog. Like common sense, people.
It's just defense. And honestly, like if somebody jumped on me, I might bite them. So like,
yeah, like
Darwin's theory proven right again. That's really what the headline should have read.
Yeah.
But I do want to pause for a second and just backtrack because I feel like a lot of our audience hasn't had a chance to meet you guys yet. And I think it would be really great just to hear about how you guys met and like how you came to both love sharks and how you found this field to study.
Yes.
You want to go first, Megan?
Sure. Yeah. So we're both early career shark scientists, but we actually met before either one of us were in shark science, which is part of what I really love about mine and Amani's collaboration. I work at a public aquarium and Amani actually lived in the area and was volunteering for me. And so she was my volunteer during her summers, I think from undergrad, right, Amani? And yeah. We got to know each other then, but we actually reconnected on science Twitter. I recently got on science Twitter and I found Amani and I was like, there's no way this is the same Amani. And also she's just such a rock star on Twitter that I was like, oh my goodness, this is the Amani I know. And she's just absolutely crushing science Twitter. You should absolutely follow her. She does.
Yeah. So both of you should share your Twitter handles and announce them so that people can follow you.
Yeah, absolutely. Amani's at @curly_biologist. I'm at Meg Holst, Holst. And so we reconnected on science Twitter and we share a love for sharks. And I was actually cherry picking episodes of podcasts where shark scientists were interviewed. And I was like, man, I'm so frustrated. I want to hear more from shark scientists. And I like can't find a place where they're all located on one. And so I was like, Amani, I have this like kind of crazy idea. I know that you're going to say no. Like you're going to tell me that this is just not a good idea. But like, what if we started a podcast and just like did it ourselves and like also got to interview those shark scientists so that we can start networking with the science field that we're entering into?
Okay, so I love this so much because years and years ago, I started the Lawfare podcast because, there were so many subjects that I didn't have time to research that were within the subject matter of Lawfare that we needed to cover. And I thought, wouldn't it be great if we had a podcast that I could just find the person who already had done the work and have a conversation with that person and do it in public. And I would have thought that shark science was a narrow enough field that one person could be essentially conversant in the whole thing. But of course, that's stupid, right? And like you actually need a podcast in order to keep up with the field. Is that like what you're saying?
Yeah. So, I mean, I didn't introduce myself. So I'm Amani Webber-Schultz. I'll just start there and then I'll answer your question. I'm also an early career shark scientist. I'm going to be starting a PhD in September. And I'm also a co-founder of a nonprofit called Minorities in Shark Sciences. Basically, we raise money and try to make a welcoming space for women of color in shark science, which is a field that women and people of color have been very historically excluded from. And I can talk more about that if we want to. But to answer your question, shark science is a very broad thing, right? So what Megan and I do is like two completely different fields. And what I do compared to the 100 other shark scientists that I know is very different. There's people who study shark brains. There's people who study shark senses. There's people who do movement ecology and like, what are they doing? Where are they going? There's people who do diet. And there's people like me who are interested in morphology. So like, why does a shark look like this? And why is this good for them in the environment that they're living in? There's conservation ecologists who are interested in how to conserve sharks because of how we are changing the climate and how we are treating them as a species. There's so many fields, which is why we were like, if we make Sharkpedia and we have these authors of papers come on and talk about it and like really bring it down to a level of someone who's not a shark scientist and can talk about these papers and learn about the research that's going on without being confused, right? Like we all know that science papers are really hard to read. Megan and I find them hard to read all the time when we do this podcast. So there's like, you can't just know everything that's going on all the time in shark science. There's like too many things.
And there's like no way that even with our podcast, we're keeping up with it. Like
exactly.
There's publications coming out. I don't know, every day, every other day. Like there's so much shark science that's coming out. Our podcast could never keep up, but we're trying to. We're also trying to display how diverse shark science is. It's not what you see on Shark Week. There's so many different topics and scientists performing the science in shark science. And that's what we're really excited about. It's just like such a diverse field. And we want people to be as intrigued and love shark science as much as we do.
So I think I've heard you guys say on your podcast that there's more than 500 species of sharks. Does that include rays or is that just sharks alone?
That is just sharks.
Okay.
So that is not including rays. And I also want to say that roughly 75 to 80% of those 500 sharks at their max length are like 3 feet. They're not all as giant as like great hammerheads that you see all the time and great whites. They're all shorter than me.
And what is the difference between a shark and a ray? Because I think most people look at a ray and say that's cute, and look at a shark and say that's scary, and look at a small shark, which, as you point out, are the vast majority, and say that's not quite really a shark. That's a dogfish. And so what are the basic subdivisions here? And to what extent are rays and sharks really the same family, and to what extent are they not?
You want to take this one, Amani?
Sure, I can start and then you can just like cover in where I miss things. So the easiest distinction between a shark and a ray is that the gills on a ray are on the bottom, right? So all sharks have their rays on the sides of their body. And rays, it's on the bottom. So for example, if you guys know what a sawfish is, that's a huge ray. They get really big, but they're not a shark. They're a ray because their gills are on the bottom of their body. Rays are also generally flattened in the way that sharks are not. Sharks have that kind of like torpedo body, and rays are all flatter. They all have those like wings on the side. That's how they move around, whereas sharks have like distinct fins all over. Megan?
Yeah, and sharks and rays are part of a group called elasmobranchs. Elasmobranchs is the family that they all belong to, and they're fish. So rays and sharks, they're all fish. Other animals that are included in elasmobranchs are also skates and chimeras. So it's a really diverse group of animals, and there are some distinct differences, like Amani was saying, with the gills is a really good giveaway between a shark and a ray, even if it's kind of difficult to see. A skate is also different than a ray. And one of the easiest ways to tell that, the difference between a skate and a ray, is if they have dorsal fins. The skates will have these big dorsal fins, whereas, oh wait, actually, I think I might be wrong about that, Amani. Can you help me out with that? Is that the way you tell the difference? See, even we question.
To be quite honest, I've like never had to tell the difference between a skate and a ray, and I don't want to say the wrong thing.
I know.
I think of rays as like curvy and skates as pointy.
I mean,
yeah, they do have like more pointy noses for sure. When you look at all the varying types of skates and rays, and then the last group in that elasmobranchs is chimeras, which are very ancient. And super weird and live in the deep sea and like look really odd.
I've never heard of them. What are they?
Oh, you need to look them up. So their common name is like a ratfish. They look like these deep sea rats, but they're so cool. Like, I don't know. They're really cool. I don't want to do any disgrace to how cool chimeras are. So you should definitely look them up. It starts with CH, not a K, chimera.
Yeah.
It sounds like a mythical beast.
It does. Well, so it is a mythical beast, but there is also chimeras, which have been around for a very long time. And from my knowledge, the easiest way to tell them apart is they have a single gill opening. So sharks in general have 5 gill slits. There are sharks that don't. 6 gills and 7 gills have 6 and 7 gills. Rays have a certain amount on the bottom as well. And chimeras have 1 instead of like multiple. And they are also, I think, all deep sea. I don't know if there are any chimeras that come up into shallower water. They don't get to be as big. And they are considered like a very ancient and distantly related to sharks and rays. There are some like extinct species of elasmobranchs. I think the one that a lot of people know is called Helicoprion, which is the one that has that like super weird like bill jaw tooth that like sits in the bottom of its jaw in a circular kind of way of like, if you imagine a snail shell, it has that similar sort of circular structure, and it sits in the bottom of its jaw, and like basically instead of the teeth falling out like with sharks, it would rotate and the teeth would become embedded back in its jaw as it needed to have more teeth. And that is considered to be a ratfish. It's considered to be more related to chimeras than it was to sharks and rays, any of the Helicoprion sharks in that genus.
All right, so I want to tell you a story about something that happened between me and my grandfather when I was 7 years old, and have you resolve a question that has been bothering me ever since my grandfather died when I was 15. So my grandfather had a stroke when I was probably 8 years old and was kind of never the same again. And so this is really my only memory of him before his stroke. When I was 7, he was an avid fisherman, and he took me fishing off of a bridge in Cape Cod. I was a little kid, and and somebody caught a fairly substantial, it looked big to me, but I was a 7-year-old, dogfish kind of shark, and it swallowed the hook, and it was gonna die because it swallowed the hook. And I was very upset about this because the fish was gonna die, and that seemed like it involved death, which is upsetting to a 7-year-old kid. And my grandfather was a doctor, and did not like that I was upset about this, and so he proudly told me that he was a doctor and he was going to do surgery and save the shark. and he took out a Swiss Army knife, and with a few elegant cuts, removed the hook from the shark, and the shark looked entirely dead, as best as I could tell, and then told me he was going to throw the shark back and it was going to be fine. And he threw the shark back off of the bridge that we were fishing off of, and a thin trail of blood off of the shark's gills where he had done the incision. And the shark merrily swam away, trailing this small amount of blood as it went. And I was entirely satisfied that he had done surgery and saved the shark. And the shark swam away, and I was thrilled. And it was not until many years later, when he died after a long illness, that I came to think about this. I was probably 15 or 16 years old, and I was like, that's a ridiculous story he told me. The shark probably died 10 minutes later, and he pulled one over on me, and it worked. And so in my mind, I have always wondered, was he telling the truth, or was he basically just bullshitting a 7-year-old because he didn't like to see me upset? So here's my question to you both. Did the shark survive?
So I will start by saying that if you ever encounter a shark in the wild and they get hooked and swallow the hook, just go ahead and cut the line. That's especially important for species that are critically endangered, like small-tooth sawfish. So if you're in Florida and you're fishing for small-tooth sawfish, they are really easily stressed and they're critically endangered, and we don't want to threaten them further. So don't panic if you get them on the line, just cut the line wherever you can reach it. Now that is possible because in fact, sharks and rays can in fact barf the hook back up. So they are pretty good at taking care of themselves. They frequently encounter things that they should not swallow in the wild. Some studies have shown pieces of cars inside sharks. Like they truly consume various things in the ocean that you would think would kill a human, but they are very robust and in fact will just barf those things back up. I also wouldn't recommend any of the listeners to cut open a shark if you do not have the permit or do not have experience safely handling that shark, because that is where it can end up posing a risk to yourself and you can get an incidental bite. It can also pose a risk to that animal. Now, I will say that sharks in general are incredible animals, and I have seen them overcome things that I absolutely was convinced would kill them. Like if another shark bit them and there's a huge, like that happens actually all the time with mating. The males will bite the females because they don't have hands, and so that's the only way for them to get leverage. And you can see some really nasty wounds from that, and they heal. They have incredible immune systems and they have incredible healing capabilities. But I wouldn't necessarily recommend doing shark surgery unless you are trained to do so.
All right. So you're saying it is possible the shark survived, but probably my grandfather was gaslighting me.
I have no idea.
It's hard to know because they are like super resilient.
It's literally my only memory of him cognismenting.
I mean, I would not recommend cutting a shark open, period, right? Like we don't want to harm them any more than we need to be, which is nothing. Again, like Megan said, last week we were doing scientific research off of Miami, and we caught a 9-foot hammerhead that had a fishing line hook like stuck in its mouth, and it was fine. Like it was swimming around, being fine. We took the hook out, we took all the line out, and it swam off. They are super resilient. We, for research purposes, will have to take a small muscle sample which involves using a super little like biopsy punch to just go through their skin really quickly. It looks like a hole punch basically. And then we'll put them back in the water and we'll catch them again a week, 2 weeks later, and you can't even tell that we took muscle from there. It's like completely healed up. So they are super resilient. But then again, especially with like critically endangered species, sharks do get stressed out, just like we get stressed out. The difference is that their stress can kill them. I guess our stress could kill us, but it would take a whole lot, whereas for them, it does not take that much to reach a threshold where they cannot pump out the acid that they secrete into their blood when they get stressed out. And so cutting that line as close as you can to them, where they're not swimming around with all this line trailing behind them, basically trying to make it so they can like live with this hook in their mouth until someone maybe removes it or their body just like ejects it out of their mouth. And I also saw a comment and Megan saying that sharks can throw up brought this up for me. Tiger sharks readily completely invert their stomach out of their mouth to get things out of their stomach that they don't want there. So for example, they eat turtles and they cannot digest the shell. And they will actually invert their entire stomach out of their body to get that out and then basically just swim with their mouth open to cram it back in their stomach.
Like when I get dirt inside a sock and I turn it inside out?
They literally, yes, that is exactly what it is. And it's really gross. I have seen it before. It is a crazy adaptation. Not all sharks, you don't want sharks to just be like throwing their stomachs up. This is something that they have evolved to do normally. If a hammerhead threw its stomach up, I would be very concerned. But yeah, tiger sharks eat like a whole bunch of random stuff and can just invert their stomach out of their mouth. And Megan commenting about sharks throwing up made me think of that.
I mean, sharks just have some really incredible adaptations.
Yeah.
So tell us about the podcast. Genevieve told me she's completely addicted to this podcast. And but for those members of the audience, including me, who've never seen it, what are you guys trying to do? And what are you covering and what are you doing with it?
Yeah. So Megan came to me with this idea, which I thought was a brilliant idea because, as I said earlier, scientific papers are really hard to read. And even as a scientist, it's really hard for me to read them, especially if it's not in an area that I know, especially if it uses words that I do not know. So she was basically like, what if we have a podcast where we read these scientific papers beforehand, we have the first author come on, and then we ask questions in the paper that maybe we didn't know or we think need to be clarified for someone who doesn't have any background knowledge to make the paper more digestible for them. So for example, we did a recent episode, I think our most recent one that came out with Jasmine Graham, who is a sawfish researcher. And we went over her first author publication and talked about sawfish, but we tried to talk about that paper and explain what that paper was in a way that is digestible to someone who does not do science or who does not know that area. So the whole purpose is really like science communication, how to make something easier to understand when you don't do it, and how to make an area that produces papers that are really hard to read more interesting to someone so they can know about all the things going on in our field.
Yeah. I think the ultimate goal is to make shark science more accessible and more exciting and easy to understand for all of our listeners. And Amani and I just basically get to hang out with really cool shark scientists that honestly, we just like get to geek out each week. And we're so excited that other people listening get to geek out with us and like ask questions to the researcher. And as we grow, we actually had the phone number for our podcast. And I'm trying to get better about sharing ahead of time when we're going to interview somebody. And our listeners can actually call in and ask questions about that paper that we can ask to the researcher. So that's something as we grow. I think we're a little small right now, so we haven't really had a huge following to submit questions. But that's something to be looking for because we would love for our audience to actually have an opportunity to ask a shark scientist about their research and have it answered on the podcast.
So I'm going to start bringing in some of our audience questions because some of them mirror quite a few questions and some topics I know you guys have touched on. But Amani, could you talk a little bit about MISS while I do that?
Yeah, sure. So Minorities in Shark Sciences, we founded it in June of 2020. Basically, the backstory of that is me and the other 3 Black women that I co-founded it with all went through our undergrad being like one of, if not the only woman of color in our marine science classes, which can be a very lonely experience because when you are a person of color, you are kind of forced to realize what environment you're in. And if you are the only one who looks a certain way, sometimes people force that in your face by making side comments about it. So we basically came together and we were like, hey, we all had this experience and we're all becoming shark scientists. We would love to create an environment for women of color and especially young kids to see people who look like them succeeding in a field that has very historically excluded them. There's a really interesting paper that just came out where a bunch of scientists basically watched all 32 years of Shark Week and made it into this paper that was like, these are the statistics of it. This is the lack of diversity. This is how many people they called shark experts but don't have any sort of MS, master's, or PhD. And it's a really interesting paper, and it sheds a lot of light on the fact.
And it's not because, all sharks are white.
No. So
or shark scientists.
Yeah. So there are like a ton of shark scientists who are already in this field who are succeeding, but you don't see them in documentaries. You don't see them on Shark Week. You don't see them in media and things like that. And so we kind of just wanted to like make a space for young kids, especially to be like, hey, I could do that because someone there is looking, someone who's doing that job and succeeding looks like me. Kids have a tendency to, if they see themselves in an adult or something like that, then they like automatically can imagine themselves in that position. But like if young me like didn't have anyone who looked like me, and so something like being on Shark Week was not an idea for 6-year-old Amani. So we have partnerships with a bunch of different things. We have partnerships with National Geographic to help diversify their Shark Fest shows. We have a partnership with the Bimini Shark Lab, which is a very famous shark lab, to send people to go do work with them. We have funding from RE Wild, which was co-founded by Leonardo DiCaprio, for a mentorship program. We basically just have like all these things that we're trying to do to create opportunities for people in the field.
Okay, so we're going to go to our first audience question. Daniel, the floor is yours.
So I'm wondering whether sharks can feel pain.
This is a great question. We just talked about this on the podcast recently.
Yep.
So this is a really, really cool adaptation for sharks. They lack a cell called nociceptors. Nociceptors are in our skin, and it feels nociception, which is the ability to feel pain or potentially harmful stimulus. So if you get a paper cut, you feel that for multiple days because we have nociceptors that are telling us, hey, there's a cut right here and it feels sensitive, and that's why it just like hurts for a few days. Sharks don't have nociceptors. It doesn't mean that they don't have nerves. They have nerves in their muscle tissue. So if they get a really bad injury, of course, they're going to feel that. But they might not necessarily be feeling this like constant painful stimulus that we feel as mammals. So that's why they can withstand something like a huge shark bite from another shark, and they can swim around with exposed organs, which yes, I have seen, and they act like nothing is wrong because they don't have nociceptors that are telling them that they're in a constant state of pain.
So I want to follow up on that because I'm fascinated by the idea of swimming around with exposed organs as though nothing's wrong. And I think that's something we should all aspire to, frankly. Pain serves an important ecological function, which is to let you know that something is wrong that requires your attention. If an organism is not experiencing pain, it's presumably not taking corrective action to not that sharks are going to perform surgery on themselves or going to go to the hospital and get stitches, but there's presumably some maybe it should go hide and not like expose itself to further attacks from whatever created the original why is it that sharks are able to go to have no experience of pain and yet not suffer significant problems as a result of that?
Yes. So it's a great question. And I'm working on my PhD right now in conservation ecology of sharks, but my master's work was actually in behavior and physiology and dabbled in neuroscience, where I looked into nociception a little bit. And so I want to bring it back a little bit to nociception, which I know can get technical, but pain is actually relative. It's a relative experience that humans describe. So if we have an injury, we have a pain scale. We can tell you, I'm having this emotional response to this pain. And that's why different people that can experience the same injury might also rate their pain differently, because there is an emotional attachment. That's also how we learn not to do that thing again that caused that injury, right? Now, the reason why nociception and the lack of having nociceptors could be really advantageous to a shark is not because they're not feeling that injury. Again, they have nerves and they're going to want to remove themselves from what caused that initial conflict or that injury. However, it can be extremely advantageous to not get a constant stimulus saying you feel like you're dying, because you're right, they can't perform surgery. They can't do anything to mitigate that injury. All they can do is move away from the thing that caused the injury. But then think about it. If somebody cut off your arm, or if you had exposed injuries, are you going to be going to work that day? Are you going to be like making breakfast? Are you going to be like moving around? No, you're not. You're going to be going to the hospital. You're in a lot of pain. You're immobile. But those sharks don't have that choice. They have to continue to try to survive and persist in that environment. So being able to shut off that like stimulus that says you're in constant pain or nociception is extremely advantageous, so that they can try to just survive.
But how are they different from other fish that way? I mean, there are other fish that are, I mean, is this a general category, a general feature of fish, which also can't go to the hospital, or is this a particular feature of sharks?
So not to get too technical, really quickly, so there are 4 types of main nerve fibers. The fastest nerve fibers are your proprioceptive fibers that tell you where you are in space, basically, like where your limbs are and give you a sense of where your body is. And this seems kind of counterintuitive, because you'd think that pain fibers are the fastest, because you'd want to know the fastest that you're all of a sudden in pain. But actually pain fibers are the least myelinated, which makes them the slowest of the 4 types of fibers. So Ben is totally correct. In people without C fibers, who are born with deformed or misformed C fibers that cannot feel pain, they typically don't survive very long, because they get secondary infections related to the pain that they're in, and they can't tell. When you have a kid with no nociceptors, they don't live very long, because they get weird cuts on their feet or other types of places, and they become infected and they never know, and their parents have to check them over multiple times. It's also there's a comorbidity with a lot of other types of genetic problems. But in short, I know that bivalves don't have pain receptors. That is pretty well proven. So mollusks and bivalves and most. So I think that Ben is correct. And the idea would probably be that when you're in some type of mono environment, like water, maybe there's a washing out and there's less of a chance of infection. Is that correct? Is a secondary infection as much of a risk?
I want to add one thing before we answer your question. The thing that we all have a tendency to do when we talk about pain in anything that's not us is apply our human emotions and experiences to the animal. which is not, that's a very large flaw that all people do when we talk about pain. Sharks have been around for hundreds of millions of years. They've been around longer than Saturn has had rings. They've been around longer than trees. And they have evolved, but not in the same way that we have. They basically were like formed and almost perfect in the way that they were formed to live in their environment. People have been around for a way shorter period of time, and we have had to evolve a ton of times because that like first sketch of a human was like not good at all for how we were supposed to live. And when we say things like, wouldn't it be advantageous to feel pain? It would be for us because of how we live our lives and because of what we are exposed to. And so when we talk about things like, oh, do sharks feel pain? Why is this like not a thing? We have to make sure that we're like separating out our personal experiences from theirs, because then we can get like completely off track of what is actually like good for them and why they don't feel pain in the same way that we do.
Right. And in terms of what you're saying about infection, now I'm going to preface this with, I don't specialize in the immune system of sharks, but I will say that they have incredible immune systems that are capable of healing and resisting bacterial infections. Like it is just truly amazing, but that's not something that I specialize in. I would love for another immunologist, I think that's what they're called, that specializes that, and sharks should absolutely comment on that. I don't know how related the nervous system of sharks is with their immune system. I'm sure it's related in some way, but that's just not my specialty.
Auntie, the floor is yours.
Thanks. So, hi guys, it's really great to be able to ask a question from you. So, you probably recognize what this is.
Megalodon tooth.
Yeah.
Oh yeah, cool.
So, are there any lessons to be learned?
While Auntie is asking this question, Auntie, hold that up against your white chair background and Genevieve, give him the full screen so people can see it.
Here we go.
Oh Lord, it's big.
Yeah, what's your question?
Yeah, so is there anything to be learned from studying megalodons and, comparing the lessons learned to today's sharks and conservation and their habitat and all these things? Yeah,
I mean, I think there is a lot to learn from extinct species of any animal. The biggest thing would be like, why is Megalodon not around anymore, right? So what changed that it's no longer advantageous to have a shark that is that large in the environment that we're currently living in? When something goes extinct, especially before people, it's because something changed that made it so that something about them was no longer good in that environment. That does not apply now, obviously, because people have a lot of things to do with animals going extinct. But historically, the biggest thing is like, why is this animal not around anymore? Something must have happened that made it so evolutionary, like in evolution, something was like, no, we don't need something this large to be in the ocean anymore because it's not advantageous to them. There are people who study extinct sharks. One of the people that we just recently interviewed on our podcast, her name is Dr. Sora Kim. She works at UC Merced and she looks at extinct sand tiger shark teeth to see things like crazy climate change and all of that stuff. So there is absolutely things to learn from extinct species. And I also just like, because this is a question that I get constantly, Megalodon is absolutely extinct. The movie The Meg is like not physically possible. We know that things like their pupping grounds were not in deep water. They were in shallow water. If there was a shark that was that large swimming around, we would know it. So I just like need to make that clear because people constantly ask after that movie The Meg came out, like if it's just in the deep sea somewhere and we don't know about it.
So I'm going to very quickly, because it's relevant, Richard, beg your patience for a second. Jeremy had a question and I tried to bring him in a couple of times. He asked, how is climate change likely to affect shark migration patterns?
That,
do you want to answer that?
I will try. I think that it's a really, that is like an excellent question. Our episode with Dr. Sora Kim will be coming out soon. So you should look for that, because I think part of the answer will be in that episode. There's a lot we don't know how sharks will respond to climate change. They've been here again since longer than Saturn's rings, longer than trees. But the climate is currently changing at a faster rate than we just don't know if they can necessarily withstand. And some species are going to be a lot more sensitive than others. So it's going to be really hard to predict, but a lot of people are currently trying to study that. What can they withstand? And especially, like, I'm currently studying the 7-gill shark for my PhD. And the only place that we know that this population pups out is in San Francisco Bay. And if you've ever been to San Francisco Bay, it is a huge bay. And it the whole bay averages 15 feet deep. Now, wow. That bay is going to absolutely be impacted by climate change, whether that's rainfall coming into the bay or, heat waves and things like that could make it more salty, things like this, that might affect the only known pupping ground that we have for this species. So understanding how climate change, I think, it's just like a really big question, but I think we're finding out.
I would also add, I think Dave said in the comments, the sharks have lived through this before. Historically, I do not think that there is a period of time where the climate has changed as rapidly as we are currently changing it. When we talk about things like the end of a glaciation period, right, the end of an ice age, or the start of a warmer climate, right, that doesn't just like happen. That is something that takes years and years and probably thousands of years to switch over the climate like that. Whereas we are changing our climate like yearly. We are seeing crazy yearly differences in things like temperature, in things like how much carbon is in our environment, in things like what animals can survive and things like that, right? So we as people are changing the climate at a pace that is probably way faster than any species have experienced before. So I would argue that like the biggest evolutionary question right now is like, can animals anywhere evolve at the rate that we are currently making it seem like they have to?
Okay, that's a great question. Richard, the floor is yours. Thank you for your patience.
No problem. So I have a serious and a not so serious and a serious question, and they're actually kind of related. So the not so serious one is, have you seen the old land shark sketches from SNL? And I'm wondering if you have, do you find them amusing or cringeworthy or whatever? The second question that's related to that, which makes, the second question is that, do you know, where do sharks actually get this reputation, the reputation that they've had for being mean, ferocious animals?
Yeah.
Is this something specific to European and American cultures, or is it universal, or are there societies that actually even venerate sharks?
Right. So I will answer your second question first. I think arguably, at least in the Western world, the turning point for sharks was when Jaws came out. My mom actually lived at the beach that they named that beach after and did not go in the ocean for like 3 months all summer. And I'm sure there are plenty of other people who did that. So in terms of Western communities, I think that like that movie was a major turning point. When you watch old Shark Week episodes, the like fear mongering is not as much as it is now, right? That has been like added in because having enough viewers, a lot of times they think is going to come from, oh my God, sharks are like man-eating people. They're trying to eat us. And like when you watch documentaries, even they have like fear mongering music or say things that make you afraid of sharks on purpose or emit some sort of emotional response from you. In terms of countries that are not Western countries, I cannot fully speak to that because I am from the US, right? I have not lived in another country that has not had access to things like Jaws. But there are a lot of coastal communities that live with sharks harmoniously. And I would guess that there is not as much sharks are terrifying as more respecting them and being like, this is where they live. I'm coming into their environment to take fish. I'm coming into their environment to get the things that I need. And if I don't bother them, they're not going to bother you. I think it is a very like Western belief that sharks are terrifying and man-eating because of how our media for the last 50 years has shown them. And the first response is, yes, I've seen the land shark SNLs. I think they're really funny, and I'm not entirely sure they cause that much harm because it's SNL, and like nobody's taking that seriously anyway.
So building on Richard's question, I just spent most of the pandemic in Wellfleet, Massachusetts, where there is currently, and I've spent most of my life at various points, like during kind of the shoulder seasons there, being on the beaches, there were never any seals, right? There were just like never any seals. And now there has been, because of climate change, apparently, that there is like this huge influx of seals to the beaches around the Outer Cape, like in the tens of thousands. And following those seals are sharks. And so, like, I mean, I really like have to tell you, I would just walk beaches for hours as a little kid and pick up all kinds of dead stuff. And everyone knows that on this show, like, totally believes that. Like,
I just want to say, when Kate says as a little kid, what she means is at 37.
Yeah.
Well, now she's rescuing alive animals.
Yeah, well, sometimes I'm rescuing live animals, like a cormorant or like a Kemp Ridley sea turtle. That's what I rescued this fall. But anyways, it was my point is that there just were never seals. I like literally never saw them. Now there are tens of thousands. There are great white sharks have come to, after years of like swimming and never having shark warnings, there are now like constant shark warnings on every beach. And sightings pretty regularly, which cause people to like leave the water and do whatever. There have been very few actual attacks. Do you think that climate change is going to have this kind of downstream effect, besides all of the bad things of climate change, of actually pushing sharks into human spaces where they really weren't even before, and now, and like kind of solidifying the fear that was at one point irrational? But now there are like a bunch of sharks around, and if you're swimming close enough, the seals are right in the water, like close to where the people are swimming. So it's not crazy that there's sharks in that area. Of course there are. So just curious what you think about that.
Yeah, I mean, I think in general, the more anthropogenic impacts, which is human-influenced impacts that we pose on the ocean, and the more climate change continues to affect sharks, the more we might see these interactions. I don't necessarily know for sure, because again, I don't specialize in that field. What I will say is that we have been culling sharks quite a bit. Historically, I don't know for sure about this location that you're talking about, but we used to have incredibly healthy, robust shark populations off of almost every coastline. Now, again, when people talk about being afraid of sharks, I just have to emphasize that the incident of shark bites happen maybe worldwide 10 times a year. However, we're killing sharks at the rate of 100 million sharks per year. 100 million. I need everyone to let that sink in for a second, because we are pulling them out so frequently. I do pretty much guarantee if you've stepped foot in the ocean, you've actually been fairly near a shark. Again, they have all these senses that they know where their environment is. They know where things are around them, but they're incredibly cautious animals. Now, that's not to say, you use some common sense. If you see a prey item like a seal in the water, yeah, I probably wouldn't get in the water. And not just because perhaps sharks might be there, but seals also, you should absolutely respect and give a distance to. If you see a pup, do not approach it, because the mother is definitely nearby and hunting probably to get food for that pup. And they can also they can have incidents with humans as well. So I think in general, when we step foot in the ocean, you absolutely need to know that you're visiting that animal's home. If you were to go in the wilderness and encounter a bear and you saw it, you wouldn't approach it. But people don't, for some reason, have that mindset when they see a shark in the wild in the ocean. So I think absolutely these encounters may happen more frequently, especially in areas where we have strong conservation efforts, and we might actually see some of these populations start to rebound. I hope that happens. I hope that shark populations will continue to rebound. But with that, we need to instill the educational resources so that people and beachgoers and people that are enjoying the water know how to properly respect those animals, respect that space, and think consciously about being in the environment where there are wild animals. We just need to have that mindset regardless of what environment you're stepping into.
So, you know, there are a lot of species of sharks, as you've said. They're around. People have a lot of engagements with them. How many of them are seriously endangered?
I don't think I know the exact number. The easiest way to find the answer, the easiest way to know the answer, at least to see what animals are listed as endangered, critically endangered, threatened, is to visit the IUCN website. They continuously do surveys, and that is what scientists generally follow in terms of what is considered critically endangered, what is threatened, what is not endangered. But that's just based on the data that we know, right? So one of the species that people see the most is a nurse shark, which are often used for ecotourism. And we make this assumption that their population is fine because we see them so often. But if you look it up, no one actually knows what their population is. There could just be a lot of them in a bunch of random spots, and like those are the only spots that they're in. And that is generally what we would term data deficient. And so when you go on their website, you will see things that say like, we don't have enough data to tell you whether this animal is endangered or not. But for example, we know that great hammerheads are critically endangered because we have enough information to feel comfortable saying that. Whereas with a nurse shark, we don't have enough information on their populations to be comfortable saying or even guessing where their populations might be.
And why is the great hammerhead such a sort of iconic image? What is the threat to it? We don't hunt it. We don't
hunt it, but we do recreationally fish for it. Florida is the recreational fishing capital of the world. People go sport fishing, which means that they go out to catch them and then release them. Hammerheads get very stressed out. So when I say stressed, when we get stressed out, right, it's like a thing that we feel. When sharks get stressed out, they secrete lactic acid into their blood. We have really big hearts. They pump all of our blood around. Sharks do not have hearts that are that large, and they don't serve the same function. One of the biggest ways that they move blood around is through their tail beats moving. That is known to be something that helps their blood move around. So great hammerheads, when you catch them, they secrete that acid into their blood at a rate faster than other sharks do. So if you are like fighting this hammerhead on the line, right? Hammerheads are super strong. They get very large. It can take a really long time to reel them in. I know because I have done this for research before. You want to be with them as short as you possibly can because they do not have hearts like we do to pump blood out. They don't have a way to metabolize that acid as quickly as they need to, and it can kill them. So fishing for hammerheads, great. Hammerheads are awesome. I'm in awe of them anytime that I'm within a foot of them. But one of the things that especially science communicators and people who work with fishers are trying to do is educate them on the different way that these sharks get stressed out and how you should be handling them and letting them go as fast as possible. So you can see pictures of people fishing for hammerheads and like dragging them up on a beach, right? If you're putting all that sand in their mouth over their gills and they're not getting water, you're essentially slowly suffocating them. And if you pull a shark up on a boat, same concept, even if it's not a hammerhead, you are taking them out of the water. They are getting stressed out because you are removing them from their environment. They're dealing with something that they probably have not dealt before, and that is dangerous to them. So I agree, hammerheads are awesome. I love them. They're so cool. But they also, like, we have to educate ourselves, especially if we're fishing for them, on how to make it as safe for them, even if we're going to enjoy this thing, right? I'm not going to tell you to stop living your life and enjoying the things that you do, but like figuring out where that happy medium is of where you can do the things that you want to do, but you're also being thoughtful of the shark are two very important things that scientists are like trying to figure out how to do.
And we're going to leave it there because we have a hard stop today at 6. And I want to thank both of our guests for coming on. Thank you guys so much. We're going to leave it there. You guys are awesome. And I have learned so much. And I hope everyone checks out your podcast because it is super informative. It's fantastic. And it's really enjoyable. We will be back Monday, August 2nd, which is exactly 71 hours from now, I think. Very excited with the math when it works out. And until then, Ben.
We don't have fun anymore, but we have many, many species of sharks, some indeterminate number of which are critically endangered, and you should leave them alone.
Thank you, everyone.
Thank you so much for having us.
Thank you